Hi, I'm David Mueller, retired hydrologist from the U.S. Geological Survey, founder of Genesis Hydrotech, and developer of QRevMS. In this video, we are going to discuss the uncertainty computations and uncertainty tab in QRevMS. QRevMS currently has the option to use either the ISO method or the IVE method. Both methods are applied to the mid and mean section methods. However, it should be noted that the IVE method was developed by the USGS for the midsection method. Both uncertainty methods are computed, and the method selected by the user in the options dialog or specified by the agency in the CFG file is highlighted in bold in the second table and is the method displayed in the lollipop graph on the Uncertainty tab and on the Main tab. The table at the left contains the default uncertainty settings expressed as a %. The other systematic uncertainty accounts for any systematic uncertainty other than the uncertainty of the instrument. The other uncertainty is assumed to be 1%. The instrument uncertainty is computed based on the manufacturer's specifications and the mean velocity of the measurement. The uncertainty for the number of stations is taken from ISO 748 table D6. The uncertainty for width is set to 0.5%, which is the maximum value suggested by ISO 748. The instrument repeatability is set to 0. The second table, the uncertainty table, expresses the uncertainties computed for the measurement in %. Both the ISO and IVE methods are computed. The method that is bold is the method selected by the user or agency. The dark cells in the table indicate that those parameters are not used by the method, but are estimated in combination with other parameters. For the ISO method, the instrument systematic uncertainty is based on the manufacturer's specifications. Systematic uncertainty is the combination of the other and instrument systematic uncertainties from the settings table. The uncertainty for the number of stations is also from the settings table. The number of cells is taken from ISO 748 table D4. The uncertainty for width is computed using the mean discharge weighted width uncertainty of each station. The uncertainty for depth is assumed to be 0.5%, which is consistent with the values suggested by ISO 748 for depths greater than 0.3 meters. The depth uncertainty is computed using the mean discharge weighted depth uncertainty for each station. The uncertainty of the velocity assumes the U sub C to be 0 and U sub E is estimated by computing the standard error of the mean velocity expressed as a percentage. The total uncertainty is the square root of the sum of the squared uncertainties. The expanded uncertainty is 2 times the total uncertainty. For the IVE method, the systematic and width uncertainties are computed the same as for the ISO method. There is no discrete accounting for the number of stations and cells or the instrument repeatability. These are accounted for in the interpolated variance estimator method used to compute the uncertainty of the depth and velocities. For details of the IVE method, refer to the paper by Cohn, Kiang, and Mason. A link is provided in the description below. The graph to the right is the same graph shown on the Main tab. The total expanded or 95% uncertainty is shown in the title. The lollipop graph shows the % contribution of each uncertainty parameter to the total uncertainty. This type of graph allows the user to see the major sources of uncertainty. Knowing the major source of uncertainty may allow the user to improve the uncertainty of future measurements. That concludes the training on QRevMS. If you are an MS user, I encourage you to go to genesishydrotech.com, Click on QRevMS, scroll down and sign up for email notifications of QRevMS updates. Also, if you find any bug, please email me with an explanation of the problem and associated data files. Thank you for your time. Hope this was helpful.